back. It's been a part of 2 weeks. Just been super busy, end of uni, stuff like that. There's a few things I want to talk about in this video, but we're mainly going to focus on housing in the UK. Got a coffee here in front of me. I'm trying not to knock that over. Basically, there's a lot of issues with housing in the UK. It's kind of on a systemic level, really badly sort of done. It's just layers and layers of bureaucracy and legislation that was designed to fix one thing and impacted another thing on the way up. I'm going to talk about housing. The first bit's going to look at UK building regs. That's very UK specific, but then the second section is going to be sort of more diverse, more general, more principles, things like that. So if you're interested in that kind of thing, stick around. With everything, all of the sort of practical things that we can do, I'm going to put at the end of the video. There'll be a timestamp coming up here on this, assuming you can see this. The next one I want to do, the next video I want to do is going to be a bit more abstract. We're going to look at nature, nurture, and sort of the idea of free will and how that's impacted by those things. So if you have any questions about any of that or any suggestions on what to look at, stick it in the comments below. Yeah, timestamps here. Topics I want to talk about today are building regs in the UK and how they differ from retrofit standards. So this sort of duality of standards, pillars of quality and comfort in buildings, specifically comfort and what makes a building feel comfortable, and then common defects and some sort of issues that we have, including damp, heating strategies, heat pumps, things like that, basically. Okay, so first thing, chapter 1. Building regs. What do I mean by building regs? So building regulations are essentially a set of legal minimum standards that a building has to meet to be signed off as fit for purpose. And there's a whole load of different documents. A lot of them are quite wordy and confusing, and a lot of them are just lists of other documents that, they refer you from one to the next. It's basically a series of British standards that buildings have to meet, and they're broken up into lots of different parts: part A, part B, part C, all the way through to sort of K, maybe even later. So let's say you're building a new home and you want to make it out of something non-conventional like clay. Well, you can look up building regs, find that whole list of British standards, and maybe somewhere in some of that it will say you're not allowed to build a building out of clay. Or maybe it won't. And it's pretty complicated to even just start digging through these things, which is why we've ended up with such a rise of sort of professional fees. So building regs, structural engineers, architects, those things take on and make up the bulk of the cost of a building project in the UK rather than the building itself. So you paying loads and loads of money to meet the standards or to even decipher the standards. And this goes out as far as biodiversity surveys, which again, there's a lot of validity in that from a sort of holistic worldview, but it's just way too over the top in paperwork. This would be a great use of AI if somebody wants to build an AI model that can sift through building regs and find out exactly what's going on. That would be really useful. Somebody jump on that. If you keep searching through the building regs, eventually you'll come across a list of conventional and non-conventional building methods, or traditional and non-traditional, I should say. So brick and block is a traditional method of building, and straw bale building is a non-traditional method of building. And I have built both. And I'll put some pictures up, or if I've got any video, I'll put some video up here. And straw bale building is really nice and structurally safe, and the difference basically comes down to the paperwork. If you can pay for a sign-off from a structural engineer, then that counts and you can get that signed off as a straw bale building. And there was plenty of precedent set for this by Barbara Jones, who's like the guru of straw bale in the UK, or certainly was a couple of decades ago. And she submitted to structural engineering and then open sourced a load of plate load tests for things like car tire foundations. So technically now there is precedent set for car tire foundations, even though it's a non-traditional building. We're sort of getting a bit sidetracked. Basically, the point I want to make is that building regs in the UK are slow, like really slow to improve. So building regs primarily applies to new homes, and there is some nuance in that, but for now let's just look at new build. So in July 2024, The Guardian ran this article, and it was basically a new build home that was sold by the developer for like 350,000, was deemed valueless due to major defects. And the key ones here you can see are inadequate damp proofing, water ingress, poor screeding, poor window design, and corroding floor beams, which feels like that's probably a significant problem. And if this was an isolated incident, then fine, but it's just not. And there was this other article that The Guardian ran earlier this year in February that details a £35 million payout due to defective pipework in a basically like new build set of high-rise flats in London that are designed for sort of super rich people. Basically, the price of the flats were astronomical, and hence there was this massive payout. But in the third paragraph in this article, it says, epidemic of similar issues. Residents being moved out of this new build tower block due to damp, and nearly £250 million worth of defects across Barratt's portfolio. This is insane. Like, Barratt is one of the biggest housing producers in the UK, and if they're getting £250 million worth of defects across their portfolio, that's an astronomical amount of defects. We've got something systemically wrong here. What makes it more insane is that so many of these issues can be avoided by two things. One, better regulation, and two, better accountability. And I want to talk about both of them. So regulation, firstly, our building rates in the UK are pretty low. They are, in fact, so low that if I buy a new build house today, it does not meet the standards that the government lays out for retrofitting houses to meet future goals. So in 2012, I think there was a set of guidance released by the government called PAS 2035, and that was basically about upgrading houses in line with sort of carbon and energy efficiency goals, and future-proofing them for a world that is changing, and temperatures are changing, and extreme weather patterns are changing. And a new build house, if you buy it today in the UK, doesn't meet those standards. Explain that to me. How does that make any sense? If I buy a brand new house off the shelf, it would immediately need extra work carrying out to bring it up to the standards that the government is laying out. So the government's building reg standards and the government's retrofit standards are so far apart from one another that buying a new build house that meets building regs immediately doesn't meet the other standard. Like, what are we doing? So the PAS 2035 framework is basically another set of documents detailing government recommendations for retrofitting houses to meet climate, energy efficiency and comfort standards. This is also mandatory for government-funded projects, but it's not mandatory for new build projects. It just doesn't make sense. Add on to that the lack of accountability for defects and for poor quality housing, and you can see why we have spent my entire lifetime in a housing crisis. Accountability is something I want to make a whole video on, because I think we've basically lost accountability in kind of all walks of life, certainly at higher than an individual level, and I think it's a really significant thing. So let me know if you have any opinions on accountability generally, and I'm going to explore that in the future. We'll talk about that. I think it's incredibly important, and the fact that we don't have any sort of politically or industrially or commercially, I think is mental. The main point I'm trying to make here is that retrofit standards, i.e. the work that we do to old buildings to improve them, are higher than new build standards, which means every single new build house that's built in the UK would immediately require retrofitting to meet the guidance that the government has laid out. I could talk a lot more about this, but I won't in this video. So the second thing I wanted to talk about, chapter 2, is the 3 key principles of sort of comfort and quality. And this might go some way to explaining a lot of the problems that we as individuals face on a day-by-day basis. So by trade, I'm a carpenter. I did some generic building work for a short period of time, but I mostly spent my time focusing on eco-building. And through that time, sort of over a decade of eco-building, I determined that that has 2 different meanings. One is ecological building, and ecological building is natural materials, straw bale, working in sort of natural environments. It's a lot of timber frame, a lot of hemp, things like that. And then the other eco-building is economical. And these 2 things can go together, but don't necessarily go together. So ecological building or natural building is one form of eco-building, and economical building, things such as the German standard passive house, is another form that is still better than traditional building, and the purpose of the sort of economical tag is that they're very energy efficient, they're very well insulated, they are sort of relatively carbon neutral. That's one of the things they're measured on. So it's still better than normal, but you can build them quite comfortably out of materials that are not good for the environment. I spent a lot of my career working on passive houses. So passive houses have some differences from building regs. They're a lot better, but fundamentally there are three key principles of building in general: airtightness, ventilation, insulation. Airtightness often gets misunderstood. So this isn't to say that the building needs to be hermetically sealed. It's not about like sealing a building so that you can't open the windows. That's not what it is. Airtightness refers to uncontrolled and unwanted air movement. So this is things like draft, cold weather ingress, air leaks, and basically any external air coming into the building. That's what airtightness aims to solve. Ventilation then refers to controlled air movement. So this is just basically anything intentional: extractor fans, mechanical ventilation, extractor hood in the kitchen. Even opening the windows technically counts as ventilation. And that is something that we're going to talk about in a minute, where basically a highly airtight building needs to have a ventilation strategy, but that ventilation strategy can be as simple as opening the windows. And then insulation refers to the structure of the building itself and its capacity to transfer heat. And so these three things are all connected and they sort of mesh together quite closely. There's no point in having really good insulation if you have really bad air tightness, because whilst the building won't be leaching heat, it will be leaking heat through leaking hot air when cold air comes in. And that's essentially makes the insulation meaningless. So going back to building regs for a second, in 2021, a new set of approved documents came out that improved building regulation. Prior to 2021, the air tightness target for a building, for building regs, was 10 meters cubed per meter squared of floor area per hour, which loosely translates, and I'm simplifying, loosely translates to the air in the building can change up to 10 times an hour, and that counts for building regs. That's signed off. In 2021, a revised version of Part K, I think it is, came out that said, okay, this needs to be lower. Let's take it to 8. So 8 times in an hour, all of the air in the building can escape and air from the outside can come in, totally uncontrolled. So this improvement sounds like a positive thing until you realise that from the 90s, there's been a standard called the Passive House Standard, which was developed in Germany. And from the 90s, to get signed off as a passive house, the maximum number of air changes per hour you can have in a building is 0.6. So our building regs in the UK are, 12, 13 and a half times worse than a standard that Germany developed in the 90s. And maybe that's too far the other way. And there's a lot of, again, discussion and debate about that. But generally speaking, you can see we're miles apart in these two camps. So that's a pretty significant difference. But what does it actually mean? Because air changes is sort of vaguely abstract. We're sat at this table. Outside it's cold. Maybe it's 5 degrees Celsius. And we have the heating on. Maybe it's set to 20 degrees. But it doesn't feel warm necessarily. Why wouldn't it feel warm if that's the case? Well, if we have a house that's built to the new building regs, the better building regs, and it has a maximum number of air changes per hour of 8, that means that every 8.5 minutes, all of the air in the building, on average, is escaping and fresh air from outside is coming in. And that air outside is 5 degrees. So your heating system, set at 20 degrees, is trying to heat up an entire house of air every 8 minutes. And obviously that's a simplification and it doesn't exactly work like that. And there's nuances in the measurements like pressure loading and stuff like that. But in principle, that's essentially what that means. Well, there's no way your heating system can heat the air in your building in 8 minutes, especially not if it's having to do it every 8 minutes. And so airtightness basically is this principle of reducing the amount of air that's escaping so that the air that we spend money heating up then stays around for us to feel warm. That's basically the point. Insulation I don't want to go into too much. It's a pretty simple principle. You basically wrap everything in something cozy and now it doesn't leach so much heat. One important thing to note is that it needs to be a consistent layer. If you have, let's say, a layer on the inside of your ground floor and a layer on the outside of your first floor, there's this gap in the middle here between the floors that will leach heat and the heat will transfer around them. And that is something called a thermal bridge. And we see it most significantly around windows and with steelwork. If you've got a big piece of cold steel that sits on the external walls of your building and it sits on top of the wall, then that steel is exposed to the cold outside air and the cold temperature of the wall. So no matter how much insulation you put on the inside of your wall, that steel is transferring heat from outside inside and onto the wall. And I'll show you some pictures of sort of isolated damp and mold problems that come from what we refer to as thermal bridges. The other place this happens really commonly is with windows. Somebody will replace their window. It will be moved to the outside skin of the building. So if you have a brick and a breeze block skin, sometimes you have cavity insulation in the middle and sometimes you don't. The window gets put onto the outside here, and then basically all of that cavity air is cold, and so you end up with this sort of line about 100 mil of mold growing inside all of the window frames, and I'll show you some photos of that. It's a really common problem. Moisture will find the coldest place in the room and condense there, and then that's what creates mold. That's all I'm going to say about insulation, and I want to talk a lot more about ventilation. All houses need air changes to maintain building health and to maintain occupancy health and comfort. Modern paints are pretty toxic. The painting and decorating has been classified by the International Agency for Research on Cancer as a carcinogenic. It's an occupational carcinogen. Basically, paints and fillers and foams are just constantly releasing toxic gases into our environment, and often it's said that this only happens whilst they're drying or in the first couple of weeks, but there have been studies done specifically in schools looking at the effect that build-up of VOCs, volatile organic compounds, which is one of the things that comes off of paint, and the effect that that has on air quality and health. So on a fundamental level, we need ventilation to keep air quality high, both because of volatile organic compounds and other gases, but also carbon dioxide, dust, and damp. So one question I get asked a lot when I talk about this stuff is, okay, if you have a passive house and your air tightness is at 0.6, how do you keep the air quality high? And the answer basically is driven ventilation. So mechanical ventilation or some other form of intentional ventilation strategy, normally managed with something called MVHR, mechanical ventilation with heat recovery. And I spent quite a lot of my time installing these systems in the end. They basically work by extracting air from warm, wet spaces, so kitchens and bathrooms, and expelling that to the outside and sucking air in from outside and putting that into living spaces, so living rooms and bedrooms mostly. And then the question is, okay, well then doesn't that have the same problem as all of the heat escaping? But the big difference is because this is intentional and controlled, you put the extracted air, the warm, wet air, through a series of fins or pipes through something called a heat exchanger. So your incoming air is in a series of very, very thin fins, and your outgoing air is in a similar series, and they cross over. They never mix, the air doesn't mix, but they cross over with enough spreading of the air so that the heat can transfer over quickly. So what this does is it basically takes that warm, wet air, takes it out of the building, takes the heat out of it, but importantly not the moisture, takes the heat, puts the heat back into the building, and takes the moisture and the cold air out. And they work really well. They're really, really good. The result of this is that often in a passive house, you can heat the whole house just with a towel rail in the bathroom. If it's well insulated and it's got good air tightness and it's got a good MVHR system, then you have one towel rail in the bathroom to dry towels, because that's another important factor that we're going to come on to, moisture. And then that hot, wet air, when it's extracted, is enough to heat the rest of the house, considering the amount of insulation that's in the house. So moving on to part 3, defects. And I specifically want to talk about damp and subsequently mold, but I have got a few extra points on things like heat pumps. So we know damp is bad, and there's a lot of data about that out there. Last year, there was a set of new regulations in the UK for renters called the Renters' Rights Act. And one of the things that got a lot of attention and has had a lot of attention in the media recently is the impact of black mold on people, but on tenants specifically. This new set of regulation that the government has released actually doesn't address mold and damp. That's always been something that's been in a rental agreement. So as a landlord, you have an obligation to remove sources of damp, but your obligation is to keep the house in a good state of repair. And the wording in this is to keep the house free from damp and mold caused by structural issues. But the majority of damp that we experience is not caused by structural issues, it's caused by behaviour, basically. Another thing that can cause damp is incorrect heating strategies. So a lot of houses in the UK are built with fireplaces. We have a lot of Victorian terraces, we have a lot of Georgian sort of semi-detached, especially here in the southwest in Bristol. So my house is a 1930s built semi-detached house. They were built in this area for coal miners. Bristol used to be a big coal mining city, and one of the things that coal miners had was a lot of coal. Every room in this house has a fireplace in it. There's 4 fireplaces in basically across 2 living rooms and 2 bedrooms, or 2 living spaces and 2 bedrooms. And that worked really well when you had fires. If you have an open fire in every room, then that's your heating strategy for the house, and the house is built with that in mind. So the house is really drafty, but because you've got a roaring fire, it needs to be drafty to suck in the air to feed the fire and to create the draft that goes up the chimney, because when you have a fire, the hot air rises, it goes up the chimney, and that sucks more air in from outside. And what this did at the time was drive out of the house that stale air, that old air, and suck in through all of the drafts, or sometimes even just through sort of ventilation bricks in the actual building work, suck in fresh air from outside. The difference with that is that if you've got 4 fires running, you've got huge amount of heat energy being produced inside the house. So it's not going to feel cold and damp because you've got this roaring fire going, even though there's basically air coming in all the time. This changed when we stopped having fires, when fires became sort of a less approved of heating strategy. They take more effort, and also in some places you have sort of bans or quite heavy regulations around having fires in buildings and having wood burners in buildings. So there was this big shift to gas boilers, and gas boilers I personally quite like, but you can see why a shift from having 4 fires in the building to having a gas boiler with a central heating system, maybe there's going to be some things that slip through the cracks there, because we haven't addressed some of the other issues that the building is going to have. We're actually facing this same problem again, this same transition in heating strategy with heat pumps. Heat pumps have been conflated with renewables, but they're not a renewable technology. They require energy to run, and that's fine, but where you get your energy from is quite important. If you're selling a heat pump as a renewable technology, the energy powering it needs to be renewable. Heat pumps are not a magic bullet. They won't work in most places. I've done a lot of work on and around heat pumps, including fixing problems that have happened because of heat pumps. I think the technology is great, but on an institutional level and on a governmental level, we just misunderstand them. I'm going to talk very briefly about heat pumps. Yes, they are more efficient than a gas boiler. Kilowatt by kilowatt, they are more efficient. Fine, whatever. Problem is they don't get as hot. So a gas boiler will take cold water and it will make it hot and it will pump it around your house. A heat pump will take cold water and it will make it warm and it will pump it around your house. So if your cold house has a gas boiler, that gas boiler makes the radiators very hot. They transfer a lot of that heat into the environment, into the air, and that's what creates that sensation of warmth. But that air is changing every 8 minutes. So the boiler is running really hot and really fast to keep the heating on. If you switch that boiler out to a heat pump without doing anything else in the building, that heat pump would have to work even harder than that gas boiler, because a heat pump can't get water hot, it can only get it warm. But if you need lots of heat to feel warm, which a boiler can just about do when you compare it to an open fire, having a fire in every room would have been better, but a boiler is still chugging away, burning loads of gas to get that heat still into your house. Because it can get things very hot, a boiler can run at like 70 degrees. A heat pump can't. It can run up to maybe 50 degrees. And because it can only get things warm, the temperature, by the time that warm water gets to your radiator, A, it's cooled down a lot, and B, that radiator isn't going to feel hot in the same way that it does with a gas boiler. That means there's just less heat being pumped out into the room. So this means that without other work on a building, if you put a heat pump in, it basically isn't going to work. If you change your gas boiler to a heat pump, the heat pump would have to work even harder than the gas boiler, which means burning even more energy. Because they can't make things hot, they can only make things warm. This basically means they would just be running all of the time, 24/7 at max capacity, but because they can't reach the same temperature and that temperature can't transfer fast enough into the building with the number of air changes that are happening, they end up just running all of the time and not making the building any more comfortable. It's true that heat pumps are more efficient, 3 to 6 times often more efficient. But it's also true that electricity is 3 to 4 times more expensive than gas. Your boiler runs on gas, your heat pump runs on electricity. So you can see that with the fact that they can't heat up the room unless you do other work, and the fact that they are essentially the same price to run, even though they are more efficient, it's basically destined to fail, especially with the way that we're approaching it. There was a thing recently, sentiment from the government following the oil problems that we've been having with the war in the Middle East, where they were suggesting that all new houses should have heat pumps installed. All new houses have way too high a heating load for a heat pump to work. So it's just destined to make more catastrophic failures for new builds. I'm going to stop talking about heat pumps. Okay, so heating strategy is important, but it needs to work with the house. Damp is just excess moisture that then finds the coldest surface, condenses to water, and then that feeds mold. And that mold is the risk to our health. Rising damp is very rarely a real thing, Penetrating damp is real, but most often damp is caused by behavior or lifestyle. And this isn't to say you need to change your lifestyle, but there's just a few things that will help. Which brings me on to, what can we do about all of this? Well, firstly, we should definitely be pushing for better building regulations. There's just such an absurd lack of intention from the government for that, and the fact that it doesn't meet other standards laid out by the government is insane to me. But the purpose of this channel is, what can we do on a personal level? What can I do to take back control of my environment? So firstly, awareness. Old stale air is unhealthy, it causes mold, it's also full of toxins, so we need to maintain airflow in buildings. This means extractor fans in bathrooms and in kitchens, and use them. This also means not putting furniture up against external walls. So any wall that is inside here, outside here, and a wall in the middle, don't put any furniture against that wall. That's the easiest way of doing it. If you do have to put furniture against that wall, space it off by at least 100 mil, at least 4 inches, but ideally more. External walls are generally colder, and that's generally one of the surfaces where, if the air isn't circulated, which is what happens behind furniture, then that air basically moisture builds up in that air, it finds that cold wall, it condenses, and you get damp. And this is why we get damp in corners of kitchens, corners of bathrooms. Those are often also external walls. If your house has mold, clean it off, ideally with vinegar, and then move the furniture away from that wall. So number two, ventilate. This means opening windows and doors if you can. In Germany, this is called Lüften. It means to ventilate, and often means opening all of the windows in the house first thing in the morning to let fresh air in and let the old stale air out. And what happens is, when you have air that's coming in and it's cold, it will have less moisture in it than air that is warm. Basically, you're letting out all of that warm, wet air, and you're letting in cold, fresh air. Wet air takes more energy to heat than dry air, and cold air holds less moisture than warm air. So cold air will heat faster than warm, wet air. The reason we do this in the mornings is because overnight you're breathing, and that breathing in that same room is creating moisture and filling it up with particles of, lung stuff and goop and spit and skin cells coming off your face. And yeah, you just want to get rid of that stuff and then let in fresh air. If, like me, your bedroom is on the ground floor and doesn't really have a way of opening a window wide, then I highly, highly recommend a good dehumidifier, if you can afford it. Don't get one of those shit 30 quid Amazon ones. Get like a decent, proper one. I'll show you some pictures of mine. I've got 2 in the house. They make a massive difference. And they make a massive difference not only to the moisture, but to the temperature. Because again, we're taking moisture out of the air, and moisture is hard to heat. Step 3, reduce moisture generation inside. So obviously you have to do day-to-day life, that's totally fine, but this means if you can, dry clothes outside, put lids on pots of boiling water, use the kitchen extractor, it is there for a reason. If you can't dry clothes outside, dry them inside in a good space with a dehumidifier. Don't put them over radiators, that's unnecessary once you've got dehumidifier. All you're doing there is transferring the heat from the radiator into that moisture, and then making the air in the room wetter, which is going to make it feel colder. Drying clothes outside is such a significant thing that in some countries, like I think Singapore particularly, I've seen a lot of tower blocks built with windows that open up onto drying racks. Yeah, essentially they're so aware of this problem that it's built into the very nature of their buildings. Like in the UK, if we live in a tower block, you often can't even open the windows more than about that much. You can see why we're just designing ourselves into failure. Okay, so what else can we do? If you live in a house, check the gutters. Blocked gutters are one of the things that causes penetrating damp. If you go outside when it's raining, it becomes really obvious. You can see a part of the gutter fills up and overflows, and that basically is going to always cause problems inside. And I'll show you a few examples of this that I will immediately find. There was one on the outside of my house, and I can show you that. And I will just go for a walk and I will see it immediately. Anywhere you see drip-like staining on the wall, that's normally because a gutter is blocked or cracked or it's come apart and it's leaking water. And that basically drives water into the brickwork and then from the brickwork into the house. And so you're getting moisture through the actual structure of the building. If your bathroom is moldy, make sure the extractor is decent and upgrade it if you need to, if you can. In the UK, we now have a new issue with a lot of places following a change in building regs a few years ago, where especially small bathrooms, they used to extract into maybe communal hallways in blocks of flats and things, and then there was a fire regulation that came in that stopped that from happening, and now we have a load of these bathrooms that no longer have extraction at all. If you have one of those bathrooms, basically all you can do is leave the door open after you've showered and have a dehumidifier. It's basically a must in those situations. I am actually working on a project to look at this problem, but I'm not making much progress in that at the moment. So as and when that is the case, I will do my best to present it here. What are we up to? 4, 5? Look after your house. Even if you don't own it, look after it. Not because it's your obligation, but because if you look after it, it will look after you. Dry clothes outside if you can. If you have a tumble dryer, make sure it extracts to the outside. If it doesn't, don't use it. It's just not worth it. Get a dehumidifier instead. You'll dry clothes in an afternoon, but it's just a lot easier and a lot nicer. It's also way cheaper to maintain a building than to repair a building. The very easiest thing we can do is open the windows in the morning and dry clothes outside. Those are 2 behavioural changes that will solve a lot of damp for a lot of people. If that's not the case for you, if you have a particular problem that you think is unique, let me know and I'll give you a call and we will try and fix it. We'll try and work out what the problem is and then we can talk about it from there. Nobody should be left with problems like this. There are other systemic, bigger issues that can occur. If you want some reading, look up the 2012 Green Deal in the UK and specifically the failures. That's a great example of a blanket scheme that just didn't work. Every house is individual, not just because they're all built differently in different places, but also because over the years more work has been done to them and that changes the building itself. Every house is individual, so every house needs an individual approach. Educate yourself, learn about your house. What type of building is it? When was it made? What's it made from? What are the common issues? Google it. If you've got a 1980s airy home, unfortunately you're in for a tough ride. And if none of this helps, drop me a message, like I said, and we can chat about it. We can work it out. Nobody should feel helpless at home. I think that's it from me for today. Let me know if I missed anything. Let me know if you prefer this style of video with the 2 camera angles. Like I said, next one is nature versus nurture and free will, so drop any suggestions below. Like and subscribe to help me out. Tell me I'm wrong, it'll help me learn. Smile at someone in the street. I'll see you soon. Ciao.